Here's an example of a much easier way to do these piecewise functions with limits than I explained in class. I don't know why this did not occur to me during class, but here's what we can do. Here's a piecewise function, so hopefully we all know how to read that by now, and here's an example of me trying to find the limit as x approaches negative infinity. All I really have to do is figure out which one of these rules applies for this limit, and then plug in some number that satisfies this condition. So for example, if I'm going to approach negative infinity, that's going to be this rule here. And if I think of a gigantically negative number, and if I were to plug it in, it would end up being, first of all, it would grow without bound. It would be gigantic. Doesn't have any kind of asymptote. And it would be 2 times the negative number, minus 5, so it would definitely be a big negative number, which means the limit as we approach negative infinity of this function would be negative infinity. If I want to approach negative 4 from the right, that means I'm going to be at negative 4, but just to the right of negative 4. So which rule does that apply to? These are numbers that are just to the right of negative 4 would be this rule. I'll take this negative 4 and plug it into this function here. So I'll take negative 4 squared, which is 16, and then subtract 4. So the limit as we approach negative 4 from the right is going to be 12. That's based off of me taking negative 4 squared minus 4. If I was going to approach negative 4 from the left, I need numbers that are very, very close to negative 4, but to the left of negative 4, or less than negative 4. That would be this rule. And I'm just going to plug negative 4 into this rule. 2 times negative 4 minus 5 is negative 13. We don't need to bother with the graph and all that kind of stuff or draw it. We can simply plug in the appropriate value into the correct rule. Moving along, here's a place where you might want to pause the video and work out these last 4. But I'm going to go ahead and talk through them right now. This would mean 3 from the left, so just to the left of 3 means I'm a little bit less than 3. Numbers that are close to 3 but less than 3 are this rule. We'll plug 3 into here. 3 squared is 9, plus 3 more is 12. I took that value, I plugged it in, got that answer. The limit as x approaches 3 from the right means I'm to the right of 3, but very close to 3. These are numbers that are very close to 3, but to the right of 3. And no matter what you plug into this function, 13 pops out. So 13 is the answer there. I want to get values that are close to 7, but less than 7. That, again, is this middle rule. That's kind of boring. So these are numbers that are close to 7, but less than 7. No matter what you plug in, 13 pops out. That limit's also 13. And then finally, the limit as we go to infinity is this rule. So I'll look at this function, and since the limit at infinity, the basic question is there any kind of asymptotic behavior here? And we know from class today that I need to look at these lead terms, and if they simplify to something, that's going to be where the asymptote is, and that's going to be the limit as we approach infinity. So the answer for this last one is going to be 1. So it's certainly a lot easier than looking at all the crazy graphs and that kind of stuff. This is obviously not the same one on your homework, but it's similar. So hopefully the homework one goes a little bit better. And good luck.